Hello students, it's from Shweta Kulkarni from Physics Department. Today we discuss about the topic semiconductors. In this session, we discussed the topic introduction, classification of elements, band formation and its type, conductor, semiconductor, insulator, effect of temperature on semiconductor, carrier generation and recombination. Before we start these topics, first point is total marks to this semiconductor is up to 9 marks. This 9 marks is divided into 5 plus 3 plus 1 or 5 plus 3 plus 2. This 5 marks is only on the base of the theoretical part. There is no problematic section on this semiconductor topic. Total 5 marks is on the base of a theoretical section only. Next important thing about this semiconductor is in this chapter the concept of the transistor means definition of the transistor, types of the transistor as NPN and PNP, its application part, transistor as an amplifier, transistor as a switch. These concepts and integrated circuit concepts are deleted from this chapter. Means one more time, concept of the transistor and integrated circuit concepts are deleted. In between that, logic gates are there, only transistor and integrated circuit concepts are deleted. Fine, we move to the next one. In introduction part, in this introduction part, first I consider single isolated system. As the name it indicate, single isolated means it contains the proton at the center and only one electron. This electron continuously revolving around the nucleus. Instead of single isolated atom, I consider the solid surface. This solid surface contains many of the atoms which are tightly bonded to one another. As I already mentioned, not of the single isolated general solid surface, it not consist only one orbit, it consists more than one, more than two or three, same at the center proton. In this case, there is a possibility of intermixing of the electron in between atoms to atom because they are tightly bonded to one another. When this intermixing of the electron from one orbit to another orbit takes place, some of the energy levels are formed. How this two type of the energy levels are formed means, if intermixing takes place, some of the electrons are collected in this level and some levels are completely empty. This filled electrons level they consider as the valence band. Valence band, before that energy band means collection of the energy level. Filled valence electron band is valence band, unfilled energy band is conduction band. Before that, valence electron means outermost orbital electron which is free to come out from this orbit. Now the point, only the outermost orbit why they consider means, as the orbit number increases at the center proton, the distance go on increases. As the distance increases, this electron and nucleus are not strong to bond one another. They are weakly bounded means this electron easily come out from this orbit. So outermost orbital electrons are known as the valence electron. Next point, classification of the elements. On the base of the 2 points, we classified the elements into conductor, semiconductor, and insulator. First point, classification on the base of the conductivity. Before that, consider conductance. To understand the conductors, I consider one substance. What's the definition? It says ability of a substance to conduct electric current through this. Here I am considering a one substance. Through this electric current is a pass. Through this electric current is a pass. If this substance allows the electric current to pass through this one, then this allowance is known as a conductance. Next, conductivity. The extent up to which an electric current flow through this is known as conductivity. ಒಂದು ಎಕ್ಸ್ಟೆಂಟ್ ತನ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಇದ್ರೊಳಗೆ ಪಾಸ್ ಆಗುತ್ತೆ. ಯಾವ ಎಷ್ಟು ಎಕ್ಸ್ಟೆಂಟ್ ತನ ಕರೆಂಟ್ ಪಾಸ್ ಆಗುತ್ತೋ ಅದರದ್ದು ಮೆಜರ್ಮೆಂಟಿಗೆ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತಾರೆ. ಇಟ್ಸ್ symbol is sigma and its SI unit is mho per meter. Next point, resistance. See, resistance means again the same substance I am considering. Resistance as definition it says opposition offered by the substance for the flow of the current. See, as the electric current is passing in this direction, some kind of the opposition if the substance offered, and that opposition is known as the resistance. ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಹೊಂಟಿತ್ತು, ಸಬ್ಸ್ಟನ್ಸ್ ಏನಾದರೂ ಅದಕ್ಕೆ ಆಪೋಸಿಷನ್ ಆಫರ್ಡ್ ಮಾಡಿದ್ರೆ ಆ ಆಪೋಸಿಷನ್ಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ರೆಸಿಸ್ಟಿವಿಟಿ, it is a measure of a resistance of a given material to electric conduction. ಈ ಮಟೀರಿಯಲ್ ಎಷ್ಟು ಆಪೋಸಿಷನ್ ಆಫರ್ಡ್ ಮಾಡುತ್ತೆ ಎಂಬುದನ್ನು ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ರೆಸಿಸ್ಟಿವಿಟಿ ಅಂತಾರೆ. ಇಟ್ಸ್ ಸಿಂಬಾಲ್ ಈಸ್ ರೋ. SI ಯೂನಿಟ್ ಈಸ್ ಓಮ್ ಪರ್ ಮೀಟರ್. ಓಮ್ ಈಸ್ ದ SI unit of resistance. Meter is SI unit of the length. On the base of this SI unit, resistivity can also be defined as resistance per unit meter. Resistance per unit meter is also resistivity. On the base of this resistivity, elements defined as the metal or conductor. They possess very low resistivity and high conductivity. Its value, resistivity value 10 raised to minus 8 to 10 minus 2 to 10 raised to minus 8. Conductivity value 10 raised to 2 to 10 raised to 8. It is a very good conductor. Semiconductor. The resistivity and conductivity lies between conductor and insulator. Their range is given here. Same insulator. It has a very high resistivity, low conductivity, and their values. On the base of the conductivity, conductor, semiconductor, and insulator. Next, classification of elements on the base of the energy band gap. We already know valence electron means the outermost orbital electrons are known as the valence band. Now, same valence band and conduction band. Valence band, name it gains, the band formed by series of energy level filled by the valence electron. Conduction band it is also same. Band means collection of the energy level, which is also known as the lowest unfilled energy level. From these two, conduction band and valence band, important point is forbidden energy gap. It is just a separation between conduction band and valence band. One more important point is energy band gap. It is most important one. Top of the valence band and bottom of the conduction band. One more time. Top of the valence band and bottom of the conduction band is known as of energy band gap. We did not consider the gap between any two level. We must consider the gap between top of the valence band and bottom of the conduction band. ಯಾವುದಾವುದೋ ಎನರ್ಜಿ ಲೆವೆಲ್ ತಗೊಂಡು ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಕನ್ಸಿಡರ್ ಮಾಡೋಕ್ಕೆ ಬರಲ್ಲ. ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಯಾವತ್ತಿದ್ರೂ ಟಾಪ್ ಆಫ್ ದ ವೆಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಬಾಟಮ್ ಆಫ್ ದ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಆನ್ ದ ಬೇಸ್ ಆಫ್ ದಿಸ್ ಎನರ್ಜಿ ಗ್ಯಾಪ್, ಫಸ್ಟ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಈಸ್ conductor. Example for the conductor are of the copper, aluminum, silicon. In this we have the two cases, case 1 and case 2. In the first case, same conduction band and valence band. In this, half of the levels are filled up by the valence gap, and energy gap, if it is there, even though it is very small. Why this energy gap it indicates? What's the use of this energy gap? Okay, to shift the electron from the valence band to the conduction band, we require the some kind of the energy. That requirement of the energy is on the base of this energy gap only. We discuss in the next point how it is to be there. In this first case, conduction band and valence band, there exists a very small gap between conduction band and a valence band. In the second case, here Eg is 0 means there is no energy gap between the conduction band and valence band, means easily electron move from the valence band to the conduction band. It does not require any external energy to shift from valence band to conduction band. Here amount of requirement of energy is very small. In this point, important point is total current is only due to electrons, not due to the holes. ಏನೂ ಗ್ಯಾಪ್ ಇರಲಿಲ್ಲ ಅಂತಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ತಂತಾನ ಮೂವ್ಮೆಂಟ್ ಆಗೋದ್ರಿಂದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಯಾವುದರಿಂದ ಜನ್ರೇಟ್ ಆಗುತ್ತಂದ್ರೆ ಕಂಪ್ಲೀಟ್ಲಿ ಬೈ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸಿಂದ. ನೆಕ್ಸ್ಟ್, ಇನ್ಸುಲೇಟರ್ ಆ್ಯಂಡ್ ಸೆಮಿಕಂಡಕ್ಟರ್. In this insulator, one absurd thing here, this valence band is completely fill up and conduction band is completely empty, and most important thing is energy gap is greater than 3 electron volt. Now the point here, this 3 electron volt, it indicates greater than 3 electron, it indicates to shift the electron from valence band to conduction band, we must supply the energy greater than 3 electron volt. Okay, now I think it's clear why this energy gap is referred for the classification, means requirement of the energy to shift the electron from the valence band to conduction band must be greater than the 3 electron volt. Now, in case of the semiconductor, valence band and conduction band, and this energy gap is less than 3 electron volt, means this band gap is lies between conductor and insulator. This gap is less than 3 electron volt. Here it is also same. To shift the electron from valence band to conduction band, requirement of energy must be less than 3 electron volt. ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಹಾಕಿದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡಿಂದ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡಿಗೆ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ. One point as I mentioned here, at 0 Kelvin, semiconductor act as an insulator. How it is to be there? 0 Kelvin ಅಂತಂದ್ರೆ ಏನೂ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಇರಂಗಿಲ್ಲ. ಏನೂ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಇರಲ್ಲ ಅಂತಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡಿಂದ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡಿಗೆ ಶಿಫ್ಟ್ ಆಗಲ್ಲ. ಎಲೆಕ್ಟ್ರಾನ್ ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡಿಂದ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡಿಗೆ ಶಿಫ್ಟ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಸೆಮಿಕಂಡಕ್ಟರ್ ಆ್ಯಕ್ಟ್ ಆಸ್ ಅನ್ insulator. Now the next point. If at 0 Kelvin semiconductor as an insulator, okay, no problem. If I increases the temperature increase ಮಾಡಿದ್ರೆ ಏನು ಪ್ರಾಪರ್ಟೀಸ್ ಚೇಂಜಸ್ ಆಗುತ್ತೆ? Okay, atoms are to be arranged one another with the help of this covalent bond. They are tightly bonded to one another. Electron sharing takes place between the atom. Now the point, if I increase the temperature, what happen? This covalent bond is break down. When this covalent bond break down ಅಂತಂದರೆ what's the meaning of that one? ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡೇವಂದ್ರೇನು, ಎನರ್ಜಿ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಈ ಅಪ್ಲೈ ಮಾಡಿರೋ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಮಾಡಿಕೊಂಡು ಕೋವೆಲೆಂಟ್ ಬಾಂಡನ್ನ ಬ್ರೇಕ್ ಮಾಡಿತು. ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗೈತಂದ್ರೆ ಏನಾಯ್ತು? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫ್ರೀ ಆಯ್ತು. ಇಟ್ಸ್ ಕಮ್ ಔಟ್ ಫ್ರಮ್ ದಿಸ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೇಮ್ ಥಿಂಗ್, ಇಫ್ ಐ ಗೋ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಟೆಂಪ್ರೇಚರ್, some of the electrons are come out by breaking of their covalent bond. As these electrons come out from this covalent bond, the empty space is created here. There is some empty space created here. Now the thing is here. If these electrons are randomly moving, means there is a possibility that this free electron may takes place in this empty space. This electron may take this empty space. Now, if there is no fill up of the any electron, as this empty space remains the same, it indicates this empty space is positively charged and they named it as an hole. Now, this hole indicates the positively charge created by the breakage of the electron, or by the breakage of covalent bond by electron. From this electron hole pair created. Now, from this one point is known the thermal emission. What is this thermal emission indicates? Before that point is electron emission. Electron emission means I consider a one metal surface. When I apply the energy to this metal surface, electrons are come out from this. In this electron emission, there are three types. One is a thermal emission, another electrical emission, another photo emission. Thermal emission, it means thermal emission ಏನು ಹೇಳುತ್ತಂದ ಅಪ್ಲೈ ಮಾಡಿರೋ ಎನರ್ಜಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್ ಇತ್ತು ಅಂತಂದ್ರೆ, ಅಂದ್ರೆ ಹೀಟಿಂಗ್ ಮಾಡಿದ್ವಿ, ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದಂದ್ರೇನು, ಹೀಟ್ ಎನರ್ಜಿ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಹೀಟ್ ಎನರ್ಜಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆ ಎನರ್ಜಿ ಗೇನ್ ಮಾಡಿ ಮೆಟಲ್ ಸರ್ಫೇಸಿಂದ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಥರ್ಮಲ್ ಎಮಿಷನ್ ಅಂತ ಕರೀತಾರೆ. ಜನರಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಮೆಟಲ್ ಸರ್ಫೇಸಿಂದ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್, ಹೀಟ್ ಎನರ್ಜಿ ಅಪ್ಲೈ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಥರ್ಮಲ್ ಎಮಿಷನ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಮಿಷನ್, ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೊರಗೆ ಬರೋದಕ್ಕೆ ಫೋಟೋ ಎಮಿಷನ್ ಅಂತ ಕರೀತಾರೆ. ತ್ರೀ ಟೈಪ್ಸ್: ಥರ್ಮಲ್ ಎಮಿಷನ್, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎಮಿಷನ್, ಫೋಟೋ ಎಮಿಷನ್. For this semiconductor, electron emission is due to thermal emission only. Next point, carrier generation and recombination. Before this previous slide. Now, as the electron hole pairs are created, we discuss electron hole pair is created. In the absence of the electric field, these electron holes are moving randomly. Holes movement ಅಂತಂದ್ರೆ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಎಲ್ಲೆಲ್ಲ ಬ್ರೇಕ್ ಹಾಕ್ಕೊಂತ ಹೋಗ್ತೈತಲ್ಲ ಅಲ್ಲಿ ಎಂಟಿ ಸ್ಪೇಸ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತಂತ ಹೋಗುತ್ತೆ. ಎಲ್ಲಿ ಬ್ರೇಕೇಜ್ ಆಗುತ್ತೆ ಹೋಲ್ಸ್ ಒಂದು ಪಾಯಿಂಟಿಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ಗೆ ಮೂವ್ಮೆಂಟ್ ಹಾಕ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಹಿಂಗೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಟ್ ಆಗೈತೆ ಅಂದ್ರೆ ಒಂದು ಹೋಲ್ ಜನ್ರೇಟ್ ಆಯ್ತು. 1 to 1 ಅಂತಂದ್ರೆ 1 electron 1 hole electron hole pair ಜನ್ರೇಟ್ ಆಯ್ತು. In the absence of the electric field, both electrons and holes are moving in the random direction. Same, most number of the electrons and the holes. If I apply the electric field, this electron hole pair, what happens? When this electric field apply, the direction of random motion of the electron is opposite to the applied electric field. ಎಲೆಕ್ಟ್ರಾನ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ಮೋಷನ್ ಆಗ್ತಿರತ್ತವ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಆದಮೇಲೆ ಅವೆಲ್ಲ ಡ್ರಿಫ್ಟ್ ಆಗ್ತಾವೆ ಅಂದ್ರೆ ಒಂದು ಕಡೆ ಸೆಟಲ್ಡ್ ಆಗ್ತಾವೆ. ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಂತಂದ್ರೆ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಅಪ್ಲೈಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ದೆನ್ ವಾಟ್ ಅಬೌಟ್ ದ ಹೋಲ್ಸ್? ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಏನಾಯ್ತು, ಸೇಮ್ ಹೋಲ್ಸ್ ರ್ಯಾಂಡಮ್ಲಿ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತಾವೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದ ಕೂಡಲೇ ಒಂದು ಸೈಡ್ ಡ್ರಿಫ್ಟ್ ಆಗ್ತಾವೆ ಅಂದ್ರೆ ಅರೇಂಜ್ಮೆಂಟ್ ಆಗ್ತಾವೆ. ಹೆಂಗೆ? ಇಟ್ ಈಸ್ ಅಲಾಂಗ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಅಪ್ಲೈಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ಡೈರೆಕ್ಷನ್ನಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇವು ಅರೇಂಜ್ಮೆಂಟ್ ಆಗುತ್ತೆ. On the base of this only, we came to know that direction of the electric current is along the direction of movement of the hole or opposite to the direction of movement of electron. One more time, direction of the electric current is on the base of movement of the hole along the direction or opposite to the direction of the movement of the electron. Next point is carrier generation and recombination. The most important thing is both the generation and recombination process are simultaneously occurs. How it is to be there? Generation means same as we increase the temperature, covalent bond breaks, electron become free, hole created. This is a generation, means electron come out, hole created, electron hole pair, generation. Recombination, same, this empty space is filled by another electron and this empty space is filled by another electron and this empty space is filled by the another electron. This is generation and recombination. Temperature increase ಮಾಡ್ದಂಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಗೇನ್ ಮಾಡ್ತು. ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಗೇನ್ ಮಾಡಿದ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿ ಹೋಲ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಯ್ತು. ಮೀನ್ಸ್ ಜನ್ರೇಷನ್ ಆಫ್ ದ ಕ್ಯಾರಿಯರ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಲ್ಸ್. ಎಂಟಿ ಸ್ಪೇಸ್ ಇದ್ದಲ್ಲೇ ಇವು ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಕೂತ್ಕೊಂಡತ್ತಂದ್ರೆ ರೀಕಾಂಬಿನೇಷನ್ ಅಂದ್ರೆ ಮತ್ತು ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಅದು. In this recombination process, some kind of the energy is released. This energy is in the form of the heat. Recombine ಹಾಕೋ ಮುಂದೆ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ದ ಹೀಟ್. ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳಬೇಕು ಅಂತಂದ್ರೆ ವಯರ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಸಪ್ಲೈ ಮಾಡೋದು ಒಳಗೆ ಏನಿರ್ತಾವೆ, ಕಾಪರ್ ವಯರ್ಸ್ ಇರ್ತೈತೆ. ಅದರ ಸುತ್ತಲೂ ಏನಿರುತ್ತೆ, ನಮ್ದು ಪ್ಲಾಸ್ಟಿಕ್ ಕೋಟಿಂಗ್ ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಸಪ್ಲೈ ಮಾಡ್ಕೊತಂದು ಹೀಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ನಾವು ಅದನ್ನು ಮುಟ್ಟಿದ ಕೂಡ ನಮಗೇನು ಹೀಟಿಂಗ್ ಸೆನ್ಸೇಷನ್ ಆಗಬಾರ್ದು ಅಂತ ಇನ್ಸುಲೇಟಿಂಗ್ ಮಟೀರಿಯಲ್ ಆಗಿ ಪ್ಲಾಸ್ಟಿಕ್ಕನ್ನು ಕೋಟಿಂಗ್ ಮಾಡಿರ್ತಾರೆ. ಓಕೆ, Fine. Now, the few questions on this session. First is classification on the base of the conductivity. And in one time in the examination, they ask for the 5 marks classification of the elements on the base of a band structure. ಬ್ಯಾಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಏನಾದರೂ ಕೇಳಿದ್ರು ಅಂತಂದ್ರೆ ಕಂಡಕ್ಟರ್ಸ್ ಅಂತ ಬರೆದು ಇವೆರಡು ಬ್ಯಾಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಹಾಕಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬರೀಬೇಕು. ಇನ್ಸುಲೇಟರ್ ದಿಸ್ ಬ್ಯಾಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಆ್ಯಂಡ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. Semiconductor band structure and explanation. Once they ask for the 5 marks. And next point, why this at 0 Kelvin semiconductor act as an insulator. The possibility question on this session: band structure formation, classification on the band structure, and why this is semiconductor act as an insulator at 0 degree Kelvin. Okay, thank you. In the next class we discuss type of the semiconductor as intrinsic, extrinsic, type of extrinsic semiconductor, n type, p type, and p and n junction formation. Thank you.